Alright, so I feel like just a little bit of a liar because the last video I made on this TESUP turbine, I said this is going to be the last video on the TESUP turbine. But it occurred to me recently that even after I made my, conclusion about this machine, that there's still people buying them. I actually still get questions about them. People ask for advice whether or not to buy one. And now I know my channel is not very large and don't have just thousands and thousands and thousands and thousands of subscribers like some of these similar channels do. But, I already tried this. It failed. It didn't work at all. Now the biggest reason why it failed was, or mechanically, the biggest reason why it failed right away was very poor manufacturing and very poor hardware. The way the machine was manufactured didn't allow the rotor to be balanced, and the hardware that was included was completely inappropriate for the purpose. No lock washers, no nylon rings, nothing to hold everything together and make sure it stayed together. So between can't balance it and can't put it together properly, fell apart in a wind. I never actually got to see this thing making power. Even if it had stayed together, though, the rotor was just completely inappropriate for the kind of power that it was producing. So the point here is that, though, people are still buying them, and a lot of people are getting stuck with them. Now, in my case, I was able to get my money back because it didn't work, fell apart. Some people haven't been so lucky. Some people haven't gotten their money back, and they're stuck with this machine. So the purpose of this series is we're going to make another rotor for it and see if we can change things around to make it work. So what we're going to start with here is we're going to show what's inside, and just an introduction to the project and showing everybody what you're getting, or what you're getting with this model. Another problem with this turbine is that there's like 4 different versions of this thing out now. So what we do with this one might not always apply, but we'll do what we can. So first step, we're going to open it up where we can see everything inside. Alright, so this is our Atlas PMA. There are no markings on it anywhere, so we don't really have any way to identify who made it. There's no way you can convince me that that TESUP is making this motor in-house. It is most likely just a generic Chinese PMA. Now, I don't say Chinese with any kind of derision. There's actually some really good PMAs coming out of China, and this might be one of them. Now, immediately, I don't like that. I mean, this thing hasn't even really been used, and the shaft is covered in rust. Same thing with this. Now, if I were looking at a go-kart with some rust on it like that, I wouldn't really be that worried. But I mean, in my environment, we should not really have that much rust on hardly anything. This is mild shaft. That's probably a mild shaft on the rotor for the PMA. Not necessarily a bad thing, but absolutely something you want to avoid if you live near the ocean. I live in a very dry area way away from the ocean. Now, for anybody not familiar, this is how TESUP is supposed to rate or supposed to get this PMA up to proper RPM. With a horizontal turbine's lower RPM, that is probably about a 10-to-1 gear ratio, and it's driven with this little belt. Now, I looked this up whenever I first did this, and this is like a 1/2 horsepower rated belt. So I have I'm pretty doubtful about how well that's going to last in real use. There are no, it's not secured to the base in any way other than these 3 brackets, which have another bracket to go to the top up here. So really, in my opinion, for 2,000 watts, this is made very, very lightly. So, I mean, even if it did make its rated power, that's, I don't know. It's just pretty light. I don't see it lasting a long time. Another thing, this top plate and the bottom plate, those are both steel. This stuff on the inside, I'm not really sure if that's steel or not. Let's find out right quick. Grab my steel detector. That plate is steel. The bracket's steel. The motor is all aluminum. That's all steel. Now, these seem to be, the powder coating on them is holding up pretty well. There's no rust, except for over here. All the hardware is such a mix. Like, that was completely uncoated bolts. But on this side, we have zinc coated bolts. They're not even the same. These are different bolts. We got these 3 are all the same. This one is different. This side, these are uncoated steel bolts. They're rusting. Zinc on the inside, but I'm pretty sure if I tried to turn those, they'd come off. Zinc bolts holding on the motor. These are coated, poorly coated zinc bolts. These are what hold the flashing onto the side, and some of the zinc is coming off. There were a couple of them that are rusted, so very inconsistent there. Zinc hardware holding that stuff together, holding the brackets to the end plates, and also holding the shaft to the end plates. It's just mostly inconsistent. Oh, and look at that one. Again, no nylon washers, no lock washers, no nylon nuts, that kind of thing. Nothing to permanently secure this. And you can see over there, my camera, well, there we go. I'll just move my camera and make it focus that way. That one is just backing off completely. Finger tight. So that would have come loose in the weather. Neat. Okay. So we're just going to do, this thing has been sitting on the shelf for a while. We're just going to do a really quick voltage check just by hand, just to kind of show what's going on here. I don't have an arbor that will let me hook my drill up to the output shaft, so I can't really test it that way. What I do with my meter, it's up here somewhere. There it is. We're just going to make sure that we do still have good voltage on all 3 phases. Also, number 10 wire, not necessarily bad. I see number 10 a lot. I mean, not 10, 12. It's number 12 wire. I see number 10 a lot, but I would like to have seen at least that with this turbine coming out of it, but it's 12. 2,000 watts on 12 gauge wire is steep. let's put the rotor mast on it. That way I can get a little bit of a grip on it and throw a consistent RPM at it. Now this is one of the things that I was concerned about whenever I was setting it up. We're at, that's 30 volts, and I'm moving at about 30 RPM. And this is supposed to be a 48 volt turbine. This is supposed to be 48 volts at 400 RPM, or 2000 watts at 400 RPM. Roughly 20 amps, somewhere in there. But I mean, the cut-in voltage on this thing is just so low. Whoops, lost my meter. Too vigorous, too vigorous. Okay, so that was those two phases. We'll try this one just to make sure. Gotta get another set of probes. Sorry for that interruption. That set of probes was dull. And they need some pointy bits. Okay. I mean, that's maybe 20 RPM. And if I just give this thing a real quick toss, it goes way over 100 volts. $150 volts. So, if you're working with this PMA, it's going to be difficult to get that to work with it's going to be difficult to get that to work with a 48 volt system. But we are going to see what we can do. We're going to start with making a real rotor for it. Since this thing is supposed to be rated for 2000 watts, we're going to try and pull off maybe a 2-meter rotor, 7 foot diameter, and I'm going to make our new blades as tall as the original ones. But yeah. Stay tuned. I'm going to have some more on this pretty soon. I definitely want to see what we can pull off with this thing. So, thanks for watching, guys. Have a wonderful day.